This video is going to be about complex fractions. Complex fractions, more or less, are two fractions being divided. So a fraction on top of a fraction. Let's do a quick review of two simple fractions to understand how this works. It's important to know that this line in the center really just means division. So it's 1/3 divided by 4/5. So let's rewrite it to understand what happens. So when we write it horizontally, we see that it's a lot like our dividing rationals. So we're going to make the reciprocal of the second one and turn the division into multiply. Go ahead and multiply straight across the numerators and the denominators. So more or less, we are flipping the bottom fraction in order to multiply them together, just like we're doing with dividing rational expressions. Okay, so let's see what this looks like with variables. So again, we want to flip the bottom one. So let's rewrite top. Sorry about that. And now instead of the division, we put multiply, and we flip the bottom. So on top, I have a 2 times 3x, and on bottom, I have a 5x. This is 6x over 5x, and our x's reduce, leaving us with 6/5. The difference in this example is that we have a little more going on in the fractions. So let's do the same thing again. Remember, we are flipping around the bottom fraction. Rewrite the top one. Now instead of the big division sign, I put multiply. Now the 35 is on top, and the x minus 2 is on bottom. Okay, you can also automatically write this as one big problem as well. And so I see that 35 and 5, 35 does go into, 5 does go to 35 and leaves you with 7. So our final answer is going to be 7 times x is 7x. 7 times 3 is 21, all over x minus 2. So now, as we work into more complex examples, let's back it off into just numbers, and then use those skills as we move into the more complex algebra expressions. So I see here that it's not as simple as just a fraction on top of a fraction. It's like there's work to do on the top and work to do on the bottom of this bigger division line right here. So let's work out the top first. Okay. So if I'm working out the top, I do need to put this 4 over 1, and now I'm going to times by 2 and by 2 in order to get common denominators. So 1/2 minus 8 over 2, and that's going to give me negative 7 over 2. Okay, now let's work on the bottom. Make sure we turn this into a single fraction as well. Let's put the 2 over 1. I need a denominator of 3, so times by 3 times by 3. I get 2 over 3 plus 6 over 3. So 2 plus 6 is 8 over 3. So I still have this big problem to do that I had in the very beginning. But now I have a single fraction on top and a single fraction on bottom. So at this point, it's time to do that flip and multiply. So negative 7 over 2 times the reciprocal of the denominator, 3 over 8. Multiply straight across, and I get negative 21 over 16. That can't be reduced anymore. So let's take a look at this problem. In this problem, I don't have a fraction on top, but I do have some fraction work on bottom. Don't need to do anything to the 3. He's already as simple as he can be. So let's work on the denominator and get this to turn into a single fraction. So I need to put that 2 over a 1. And now I need to get the denominators the same. That'd be an x. So let's times by x to both of these. Now I end up with 2 over x plus 2x over x. This gives me 2 plus 2x. They're not like terms, so I don't combine them, over an x. So now I have one single fraction. Remember, I still have this 3 over the bigger division line. So now it's time to flip. Okay, we're going to flip this, and instead of write that division, we're going to write it as multiply. So now I have 3 times x over 2 plus 2x. Now you see, I don't have a fraction out of the 3, so we can put the 3 over a 1, and now I have 2 fractions. So my final answer would be 3 times x is 3x, all over 1 times 2 is 2, 1 times 2x is 2x. I know it looks like you should be able to cross off these x's, but remember the 2 and the 2x are together as one thing. So I cannot get rid of the x unless I also get rid of the 2 and the plus 2. So this is where we have to end with our answer. Okay, so that is how you simplify complex fractions. If you have any questions, go ahead and leave a comment or email me, and I will see you back in class.